Alright, in this lesson I'm going to show you guys how to solve another second degree trig equation, but now with the tan ratio. So looking at this equation here, you'll notice it's squared here. So when you see a squared, first thing you should do is actually bring everything to one side, and potentially factoring could come up. So to keep this positive, I'm going to bring everything from the right hand side to the left hand side. So as a result, I'm going to have tan squared theta minus 2 tan theta, and minus 5 minus a 3 gives you minus 8 is equal to 0. So let's see if this is PSable, because it does follow a quadratic pattern. Product would be negative 8, and sum would be negative 2. So two numbers would be 4 and 2, and the 4 should be negative here. So as a result here, I have tan squared theta minus 4 tan theta plus 2 tan theta, and minus an 8, which is equal to 0. So first thing now, or so second thing we need to do here is group those terms. So group the first two terms, group the last two terms, and factor out whatever's common. So tan theta can come out here, and I have tan theta minus 4. Second grouping is I could take out a 2, so I'm left with tan theta minus 4. So finally, my two factors are as follows. I have tan theta minus 4, that's one factor, and the other one is tan theta plus 2. Okay, and this is all equal to 0. So therefore, I have two equations to solve here. First equation is when tan theta is equal to positive 4. Second equation is when tan theta is equal to negative 2. So unit circle is not going to work here because there's no way there's a x and y coordinate that gives a ratio of 2 and negative 2. 4 and negative 2. So we have to use a mix of using a reference angle and the cast rule. So let's say I want to solve the first equation, which is tan theta is equal to 4. So find out where these angles could lie. Since tan is positive here, I'm going to use add sugar to coffee to find out that two solutions are in quadrant 1. One solution is in quadrant 3. Okay, so we need to find out what is that reference angle before we identify these angles. So let's find that reference angle by taking the tan inverse of positive 4. To take the tan inverse of positive 4, go in your calculator here and clear whatever's there. Make sure you're in the right mode, so you should be in degree mode. So go second tan inverse of positive 4, and my reference angle is 75.9, which is also 76 degrees. Okay, so that doesn't mean it's a solution, but to go back to the diagram, this is 76.0 degrees, and this is 76.0 degrees. So my two solutions are as follows. First solution is exactly what the reference angle is. So theta 1 will be equal to 76.0 degrees. And the second solution is this rotation here. To get that standard angle here, we're going to go theta 2, 180 degrees plus 76.0 degrees. And that will give me the second solution. So go into the calculator here, just take that value that you currently have and add 180. And we get our second solution, which is 255.9, which is 256, rounded properly. All right, so here are my two solutions so far. But we have another equation to address here, which is this one here. Okay, so like I said before, find out where these angles could lie. So we're going to draw a new diagram here. Tan is negative this time, so using add sugar to coffee, where is tan negative? You'll see that tan is negative in quadrant 2 and quadrant 4. So find out what the reference angles are, which is these two angles here. So take the tan inverse of positive 2. Remember, it's always positive there because reference angles are always positive. So second tan 2 is equal to a reference angle of 63.4 degrees. Okay, so this angle right here is 63.4 degrees, and same thing here. So let's identify these two solutions here. So first solution is from the x-axis to that terminal arm. To get that rotation angle, which I'll call theta 3, it's 180 subtract 63.4. So let's find out what that angle is. So 180 subtract 63.4, or you can use the previous answer, doesn't matter. 116.6 degrees is the first or third solution, I should say. So 116, sorry, 0.6 degrees. That's the third solution. And the fourth final solution is all the way down here. So to get that rotation angle, I'm going to call it theta 4. You want to take 360 degrees and subtract the reference angle, which was 63.4 degrees. And I swear this should be the last step here. So 360 minus 63.4 gives me a final solution of 296.6 degrees. Okay, so here's solution 4, solution 3, and the other two solutions were up here.